Welcome to today's deep dive. I'm really glad you could join us for this one because we are looking at a massive dilemma that basically every single one of us is facing right now.
Yeah, it's something you really can't ignore anymore.
Exactly. I mean, we are all watching this incredible explosive rise of AI. It feels like every week there's a new breakthrough, right?
Right, the pace is just staggering.
But there is a terrifying secret underlying all of this, and that is the fact that the foundation this whole AI revolution is being built upon is incredibly fragile.
Extremely
We're
fragile.
essentially building a 100-story skyscraper, but we're building it on a foundation of sand.
Yeah, it is arguably the most critical vulnerability in modern technology today. The capabilities of these AI systems are accelerating at a pace we've never seen, but the underlying architecture,
The plumbing,
right, the actual plumbing for how we secure, deploy, and trust these systems, it just hasn't kept up with the intelligence of the models themselves.
which brings us to today's stack of sources. We are looking at a provisional patent application. It's a document titled sealed.pdf, and it details something called a sealed computation environment.
A really fascinating technical document.
It really is. And alongside that, we have a series of essays by an author named Greg. These essays break down what he calls the Safebox stack, and they lay out a very specific roadmap for the future of AI architecture.
And the stakes here are quite high.
Oh, absolutely. The mission of our deep dive today is to explore how this specific technology, this Safebox, can fundamentally change the world for the better.
Because if we continue building AI the way we are right now, we are heading for a dangerous collapse of our digital infrastructure.
But if we get this right, it paves the way for what the author calls Web4,
Right.
an entirely new, secure internet that protects regular people and massive institutions alike.
It's really about moving away from this era where a tech company just says, trust our privacy policies.
Right, the whole just trust us era.
Exactly. Shifting to a world where they have to say, here is the verifiable mathematical proof that your data is safe.
It's a huge shift.
It's the core shift. We are moving from trust our procedures to verify our mathematics. It's a fundamental rewiring of digital trust.
Okay, let's unpack this.
Yeah.
Because right now, AI forces us into this impossible false choice. It's the cloud versus local dilemma.
Yeah, you see this debate everywhere.
Right. On one hand, you can use the massive cloud giants to run your AI, but if you do that, you're flying blind. You are trusting that they aren't cherry-picking the outputs, that they aren't mishandling your prompts.
Or that their system operators aren't snooping on your data behind the scenes.
Exactly. And for casual everyday use, many people seem willing to accept that trade-off.
They do, but think about regulated industries, finance, healthcare, legal systems,
Oh, sure.
or even just individuals who place a high value on their personal privacy. For them, blind trust is a completely unacceptable foundation for doing business.
I hear that. But let me play devil's advocate for a second here. People already have a solution for cloud snooping, don't they? They just run things locally on their own machines.
What?
The sources even mention this. Look at something like OpenClaw. It has been downloaded incredibly fast, faster than almost all other software right now.
Right, it's massively popular.
Or people running standard media tools like FFmpeg locally with AI. If I own the hardware and I run it in my own house or office, aren't I safe?
It definitely feels that way, doesn't it? You own the laptop, you own the software. But the texts point out that local computing is actually a massive, dangerous illusion.
Illusion.
Yes. When you run things locally, you fragment the environment. You end up with different versions of software across different machines. You get library conflicts.
The classic, well, it works on my machine problem in IT.
Exactly. But the real issue is the absolute security nightmare it creates.
How so?
By running these powerful models locally without centralized verifiable security, you turn every single employee's laptop into a massive attack surface.
Yeah.
A local machine is inherently vulnerable to unpatched operating systems, rogue browser extensions, or just simple human error.
To put this in perspective for you listening, imagine downloading one of these highly popular local AI tools. You grab OpenClaw because it's fast and free, but running these local models without the proper architecture acts almost like a Trojan horse.
It does.
It leaves regular people totally exposed to getting pooned without even realizing it. There are no central audit trails. And for a
It's an absolute compliance hell.
Right.
Imagine trying to explain to an auditor that you are handling medical records under HIPAA regulations or European data under GDPR, but that patient data is sitting on 50 different employee laptops?
With zero mathematical proof of how it's being processed.
Exactly. You cannot audit chaos.
And that brings us to the core architectural flaw in how AI is being deployed right now. The sources vividly describe this using the metaphor of sandcastles versus steel skeletons.
It's a brilliant way to conceptualize the problem. Right now, most AI agent systems are built exactly like sandcastles or beehives.
Beehives, yeah.
They're glued together with text prompts. They rely heavily on what developers casually call vibes.
Vibes.
Yeah, vibes and emergent behavior. You have these swarms of agents passing information around, self-modifying, trying to figure out how to reach a goal on the fly.
Which, to be fair, looks incredibly impressive in a demo video. It feels alive and adaptable.
It does. But you have to ask yourself, what happens when things go wrong? And they inevitably will go wrong.
Right.
When a sandcastle fails, let's say because a model provider changes how their software talks to other software in API update, or because of something called prompt drift, the failure is entirely opaque.
Let's define prompt drift really quickly for anyone who hasn't encountered it. That's when the underlying AI model gets a silent update from the developer, and suddenly the exact same text prompt you've been using for months starts generating completely different weird results. Right.
Exactly that. The foundation shifts underneath you without warning. And when that happens, you cannot debug a swarm of agents that made a mistake based on emergent vibes. You cannot run critical infrastructure, finance, or safety systems on a beehive.
Because when it fails, it cascades. You can't point to the specific beam that broke.
The essay makes a crucial distinction here. Frameworks are architecture, while agents are just the occupants.
I love that line.
It's so accurate. You don't let the tenants design the load-bearing walls of an apartment building, and you certainly don't let insects decide how a skyscraper is reinforced.
Right.
An AI system requires deterministic replay, explicit schemas, and strict capability boundaries.
Let's translate those terms because they are so important. Explicit schemas means having strict, unbendable blueprints for exactly what kind of data the AI is allowed to output.
Yes.
And deterministic replay.
Deterministic replay means predictability. If you give the AI system the exact same inputs, it must take the exact same steps and give you the exact same answer every single time.
No randomness.
None. It cannot rely on randomness. It has to be as predictable as a calculator.
So the antidote to the sandcastle is what the author calls a load-bearing semantic skeleton. It's a rigid framework that the AI agents operate inside of, rather than letting the agents define the rules as they go.
And realizing that structural requirement is exactly what leads us to the technical solution proposed in the patent documentation.
Here's where it gets really interesting. Enter Safebox.
The foundation of Web4.
Exactly. This is where organizations can finally get verifiable computing without relying blindly on the cloud giants, and without suffering the chaotic Trojan horse of local setups.
To understand how Safebox achieves this, we have to look at the hardware attestation mentioned in the patent.
Okay.
A Safebox is a sealed computation environment. It uses specialized physical hardware mechanisms. The text mentions systems like AWS Nitro Enclaves or Intel SGX.
What does that actually mean in plain English?
Think of it like a digital vault forged out of math and silicon.
A digital vault.
Right. This hardware mathematically proves that it is running approved, unmodified code. The data inside this vault is encrypted. Once it is inside, it is completely inaccessible to everyone.
Everyone.
Everyone. The system operators can't see it. The administrators can't see it. Even the CEO of the cloud company hosting the physical server cannot peek inside that vault.
Okay, wait, help me visualize this because this was a massive aha moment for me in the sources.
Sure.
Usually, if I want an AI to analyze, say, 1 million hospital records to find a new cure, the AI has to read those records. And to read them, the data has to be unencrypted and exposed in the computer's memory. How does a Safebox calculate the answer without exposing the data to the people running the machine?
Because the decryption and the processing happen entirely inside the locked hardware vault. The data goes in encrypted. The hardware verifies the code, unlocks the data internally, runs the AI model, re-encrypts the final answer, and spits only that answer back out. No human ever sees the raw data during the process. which actually eliminates the need for a very common security workaround called differential privacy.
Right, because normally, to protect data, companies use differential privacy, which basically means injecting statistical noise into a data set.
Yes, adding noise.
It deliberately makes the data slightly fuzzy or inaccurate, so you can't trace a specific medical record back to an individual person. It's like blurring a crowd photo so you can count how many people are there without recognizing any faces.
But with Safebox, you don't need to blur the photo. You don't need the noise.
That is incredible.
The system can compute exact, 100% accurate statistics and output the final aggregated numbers without ever exposing the individual records.
Think about the implications for medical research or complex market forecasting. You get perfect accuracy with zero privacy loss.
Zero.
That is wild, but even with a digital vault, someone still has to tell the vault what to do. And the way data is accessed in this system is just as revolutionary. The patent introduces the concept of warrant-governed execution.
A profound concept.
And it stresses that this is not merely a company policy written in a terms of service agreement that nobody reads. It is the technical equivalent of the Fourth Amendment.
We are talking about a multi-party cryptographic warrant. To access any data or trigger any external action from the Safebox, a multi-party cryptographic signature is required.
Okay, break that down.
For example, to open a specific data set, the vault might require a digital key from a judicial authority, another key from an organizational oversight committee, and a third key from a data subject representative.
So it's like a nuclear submarine where two people have to turn the keys at the exact same time.
Yes.
But done with cryptography.
Precisely. And the environment mathematically refuses to execute the request unless all valid cryptographic signatures are present simultaneously.
Looking at the sources, there's a fascinating neutral observation here regarding the broader implications. Whether you are worried about corporate tracking or government surveillance, this technology acts as a hard, mathematically enforced barrier against bulk data collection.
It does.
It ensures that access to data is strictly limited, narrowly scoped, and absolutely bound by math, regardless of who is asking for it. It literally replaces human discretion with mathematical impossibility.
The system simply cannot process a request that doesn't carry the exact proof of authorization.
Right.
It takes the human element, human error, human corruption, human coercion, completely out of the loop.
But of course, philosophy and grand architectural ideas are great, but they don't change the world unless businesses actually want to adopt them.
They have to be practical.
So true. The best tech in the world goes absolutely nowhere if companies won't buy it. And the sources focus heavily on how this actually gets adopted in the real world by fixing something called SOC2 compliance.
Oh, SOC2. For anyone who hasn't had the pleasure of living through it, SOC2 is basically every software company's nightmare.
A total nightmare.
It is the massive audit you have to pass to prove to enterprise clients like banks or hospitals that you are handling their data securely.
The financial and time costs associated with this are staggering. The texts outline that a traditional SOC2 audit takes 4 to 6 months. It costs anywhere from $50,000 to $500,000.
And what are you actually paying for?
Right.
You are paying human auditors to manually pest if you are following your own security procedures. They literally walk around asking, do you have a firewall configured? Did you train your employees not to click on phishing links?
It is entirely manual and process-driven.
Yeah.
But Safebox replaces manual audits with mathematical proof.
Yes.
You aren't paying an auditor to read a document about your procedures. You are deploying verifiable infrastructure that proves it is secure by default.
Because of that, the text projects the cost of an audit dropping drastically, down to between $10,000 and $25,000.
Like a massive drop.
And the timeline shrinking from half a year to just 2 to 4 weeks.
It's essentially using corporate cost-cutting as a Trojan horse to secure the whole internet. Companies will adopt it just to save money, but the ripple effect for regular people and regulated institutions is massive.
It's huge.
We're talking about industry-specific compliance templates. Imagine a healthcare template for HIPAA or a financial template for banking. You just load the Safebox template and you are compliant.
If we connect this to the bigger picture, the network effects here become unstoppable. Once a few major hospital systems or massive banks adopt this architecture to save on their own compliance costs, they will naturally start demanding it from all of their third-party vendors.
Right. because why wouldn't they?
Exactly. Suddenly, those endless 100-page customer security questionnaires that businesses send each other become completely obsolete.
Because you don't have to take the vendor's word for it anymore. You don't have to trust their questionnaire. They just provide the cryptographic proof that they are running your data inside a Safebox template.
It's verifiable.
It means real enterprise-grade security becomes accessible to small startups. You don't need a $500,000 compliance budget just to get your foot in the door to sell software to a bank. You just need the right mathematical architecture.
It fundamentally levels the playing field for innovation. Startups can compete with massive incumbents because trust is no longer based on brand reputation. It's based on math.
Right.
But it also sets up a really fascinating dynamic for the future of AI development itself.
Which brings us to the final essay we're looking at today. Why SafeBots will win the AI arms race. It poses such a great question to you, the listener. If you look at the long run of this technology, who actually wins? The absolute smartest, most cutting-edge AI, or the most deployable one?
The author uses a brilliant historical pattern to explain this. Throughout human history, brilliant individuals, geniuses, do not rule the world. Cities and institutions rule the world.
Cities?
Why? Because cities control the resources, the infrastructure, the roads, the sewers, the stability. In this grand metaphor, the frontier AI models, those brilliant, chaotic agent swarms we talked about earlier, they are the fragile geniuses.
And Safebox is the city.
Yes. Infrastructure always absorbs intelligence. The frontier models, the super smart AIs, they won't disappear, but they will be forced to operate inside the Safebox architecture.
Because that is where the trust, the compliance, and the massive enterprise resources are located. A genius still needs to live in a house and use the power grid.
Exactly. And the city has its own economy.
Right. The sources introduced this concept called SafeBX.
Yes, SafeBX.
Which acts as the currency of this new digital city. It's used to automatically settle model inference and tool usage. If an AI agent wants to use a specific tool to automate a web browser or run a database query, it settles that microtransaction using SafeBX.
It creates a closed-loop economy that directly rewards the developers building the tools and the providers hosting the models.
It beautifully aligns the economic incentives with the architectural security.
The Safebox ecosystem doesn't care if one AI model is 5% smarter than another. It cares that the model is operating within an auditable, verifiable framework that institutions can actually trust and pay for securely.
And the author lays out a very specific, fascinating 10-year timeline for how this AI arms race plays out. According to the text, right now, between 2026 and 2027, we are in the swarm hype phase.
Yes, the hype phase.
Agent swarms are dominating the headlines, everyone is mesmerized by the demos, and the sandcastles are being built higher and higher.
But then we hit reality. In 2028 and 2029, we enter what the author calls institutional friction.
Friction.
This is when those impressive swarms start failing in real-world production environments. The APIs break, the prompts drift, the regulatory pressure from governments mounts, and major enterprises realize they absolutely require determinism and mathematical safety to operate.
Then the big pivot happens around 2030 to 2031. We see the infrastructure shift.
The massive multi-billion-dollar compute budgets start moving.
Moving away from the fragile sandcastles and toward verifiable substrates like Safebox, the brilliant frontier models realize they have to start integrating into this city architecture just to get access to that enterprise compute.
Which all culminates in the 2034 to 2035 window, a period the author labels the honey badger phase.
I love that name, the honey badger phase.
It's fitting. It implies that by this point, Safebox is everywhere. It is boring, it is slow-moving, it doesn't care about the hype, and it is quietly running the operational workflows of the world.
The chaotic, wild intelligence of the swarms have been entirely absorbed into a stable, verifiable infrastructure that fiercely protects its data.
Exactly.
So what does this all mean? If we pull all these sources together, from the patent to the essays, we are standing at the edge of a massive transition.
A historic one.
We are moving away from a world of trust me cloud servers that hold all our sensitive data in the dark, and we are moving away from the dangerous, fragmented world of local computing where downloading the newest AI tool is like inviting a Trojan horse right onto your hard drive.
Instead, we are moving toward a world governed by verifiable mathematical proof.
This protects you, the everyday user, from getting compromised. And it gives massive institutions the actual safety they need to deploy AI at a global scale.
Ultimately, verifiable infrastructure distributes power. It takes control away from a handful of massive tech monopolies who currently act as the gatekeepers of trust, and it puts that control back into the hands of the data owners.
You are no longer asking for permission or hoping for privacy.
Though you're relying on hard architectural guarantees.
It is a profound shift in how the internet works. And it leaves us with a final provocative thought for you to mull over as we wrap up.
Oh, this is a good one.
If Safeboxes really do become the impenetrable, wealthy cities of the future, absorbing all the smartest AI and all the enterprise money, what happens to the wild open source frontier?
Right.
If our digital infrastructure soon requires multi-party cryptographic warrants just to look at our data, how will that shift the balance of power between everyday citizens and the massive organizations that are used to holding all the keys? Something to ponder. Thanks for joining us on this deep dive. We will see you next time.